Alright, so in the last video, we finally wrapped up our stadium and our bleachers.
Yeah, it's looking really good. We've got our support beams in place, giving it stability. We've got the bleacher copied around, or the bench, copied around to all the rows and columns. So in this video, it's time for us to turn our attention to the crowd. This is going to be a very simple crowd simulation system. It is going to serve as a proof of concept because the cool thing is we can simply take our crowd system. So let's just say that here's our crowd system. We can simply take it where it's being plugged into the rest of the network. We can pull it out. We can bring in a much more sophisticated crowd system, plug it in instead, and boom, we just have it. And that is the beauty of Houdini. Now, if you recall, all the way back at the beginning of this DVD when we went over the storyboards, the Talented Ball will be performing for an audience. That audience is going to be made up of a bunch of spheres. These spheres will each have their own characteristics, so we'll have large ones, small ones, so all sorts of different sizes, and they're going to have different looks as well. So one guy might have, this is just for a very quick representation, square eyes, somebody else might have small eyes, this guy might have little dots, this guy might have, just throw some quick slits in there. And then for, mouths might have just a straight line, he's not too happy. This guy's kind of in shock, this guy's definitely in shock, and this guy's very happy.
Cool.
But the nice thing is, what we're going to do is create a single sphere. So these guys are all descendants of this sphere. But we have seen the power of stamping in Houdini as we have worked our way through this project. And stamping is going to serve as the backbone to drive the various looks we're going to get out of the spheres.
It truly gives us something incredibly powerful to work with.
So basically down here where the spheres are getting copied, we have that information getting stamped all the way back up, and the information is going to be used in our SOPS network, and it's also going to be used in our custom shader as well, so that we generate the right colors, the right shading that's going to be applied to each of our sphere characters, giving these different looks. And that's really some cool stuff. But in the end, we're going to simply take the result of all of this and copy that to our benches, because it's the benches that our spheres need to sit on. So that means our benches are going to need points. Now we've all seen that if we were to take a line or anything that's got points and take this type of data and feed this into a copy on the template side and feed something like a sphere into the source side, the result coming out is going to be such that our source geometry is copied to each of our points. And this is going to be the technique we're going to use to place our crowd onto the seats. Okay? So right here, if instead of a sphere we had something much more involved, that it would be a humanoid type character, or maybe some sort of really weird alien that has two heads and all sorts of arms. The nice thing is these guys can simply be plugged in. And by doing that, the crowd that is seen on the benches will be different. And that's really nice. So that's why I like to call this a proof of concept. So in this video, we're going to talk about how those points are going to be created. So we're going to have a bench.
And it's worth noting right now that we're going to be breaking these down into very short videos, just as we did for the bleachers, keep things nice and simple and keep things focused on the problem at hand. Very focused,
that's right. But first, before we start getting into the meat of it, let's just give them a very generic overview.
Oh, cool.
So how about, we know that we have our bench sitting there at the origin. What we're going to do is create a line in this video. This line is going to sit on top, just right flush on top of the seat itself, and we'll start out with 2 points. Now we know that where we have points, we will have characters copied too. So we need a parameter because we need some sort of ability to put more points on a line. So we're going to create a custom parameter up at the asset level called max balls per bench. So max balls per bench. this guy is going to be locked to a minimum of 1. Okay, because we don't want to set it to 0. Just for starters, if we look at this line, having 0 points is what we would need to have no balls copied, right? Doesn't make sense, first of all. Maximum numbers per bench, 0.
Yeah, we wouldn't have a crowd.
We wouldn't have a crowd, so what would be the point of going in and playing with crowd numbers to begin with? So we're going to lock it to a minimum of 1. But let's talk about that. That's going to put us into a very unique situation because we've got 2 points on this line, and there's no way that you can go into a line stop and reduce the number of points such that our line is comprised of a single point. That is impossible. For a line to exist, you must have at least 2 points. Feel free to try it if you don't believe me. Houdini will say no, and will always reset your point number back to 2.
Yeah, because the parameter's locked with a minimum of 2.
Now, you're probably thinking to yourself, but wait a minute, that means that every single seat will have some sort of character sitting on it. There will always be characters on every seat. In the future, as we work our way up through the system, we will set up a toggle that will enable our network to calculate our crowd distribution in such a way that some of our benches may be empty. And that gives kind of a more natural look to an audience when an audience, or a stadium, is not completely packed out. So that, though, will not be driven by the maximum balls per bench. So we're going to create this line and we're going to position it up on top. Let's go ahead and put that together real quick. We'll begin with a very simple line stop. And with the line stop, we'll start out with a direction, and I'm sure everybody knows the direction. We know that the bench itself has a width being controlled in the x-axis, so the direction would obviously be x. So we'll simply set x to a positive value of 1, y and z to 0. Now we need to move our line up off of the construction grid, so much so that it is sitting flush on top of our bench, and we can do that with a very simple expression on the origin y of our line. We'll simply say, look, take this guy and move him up the distance that our box has been moved up. So let me just draw, let's look at the side right here. So just this area as being a side profile of this guy. So we've moved him up to right there. If we were to move up in the boxes, translate y, so that's where he's positioned at, that was a y, not an x. Can't believe I actually wrote X. So if we've moved it up, that means our line will be sitting in the middle. So we need to move them up just a little bit more. How much is a little bit more? How about we just take 1/2 of the thickness of our bench and then add that on to the result of this, and that will put us sitting right here on the top of the bench itself.
Yeah, and that thickness is the size y parameter.
That's right. So we'll just simply add I'll just put size y as sy divided by 2.
Cool.
Okay? And now we need to come up with the length of it. We'll do that in just a second. Let's go ahead and position it such that it is centered up, because we know that, let's say x is going in this direction positively. If we say that the line is going to go in a positive direction by default, point 0 begins at 0, and then we go in a positive direction. So here is the center of the world, but we want our line centered up on the center, and you can see that in the drawing that we've got right there. So this line right here, the center would actually be right about here. So in order to do that, we'll simply affect the origin in x. Origin in x will be take the distance, we'll just move it back, though it doesn't matter which direction we move it, really.
Yeah, because if we have our direction in x as -1, we could take the positive distance,
Yeah.
and since we've got our direction of x being a +1, we want to move back in x to offset.
Exactly. So we'll simply say, all right, before we change the length of this guy, let's go ahead and set the distance, divide it by 2. That takes him, let's say, he's 1, it moves him back -0.5, and now he's centered up as seen right here. Next thing we'll do is we'll get him scaled up. So for doing this, we're just going to set the distance, which starts out at 1, but we're not interested in that value of 1. What we're interested in is just how wide is our bench. Okay, now remember, as we set this parameter, when the network cooks and each new bench gets copied, this information is going to change because our benches get wider and wider and wider the further we go up our rows. So we'll simply set our distance to be the box's size in x times Now here's the kicker. We're not going to multiply it by 1 or just leave it at box size in X. We're going to multiply it by 0.9 so that we're 10% smaller or 10% narrower than the width of the bench itself. That is why in this particular case I have drawn this guy where he is actually sized in a little bit, as you can see here, from the overall width of the bench. This is important. We don't want our line to come all the way out to the edges. Well, first of all, let's just think about it. We don't want any balls ending up with the possibility of sitting on the edges themselves.
It just wouldn't look natural.
It just wouldn't look right. So we'll make sure that we scale the line in just a little bit. So we'll set that up, and then finally, the most important thing as far as I'm concerned is the points. How many points will we be creating on this line? Let's all think about this. By default, the line has 2 points. We want more than 2 points because we know that it will be the points in the end that will dictate where our balls will be copied to. We don't want these lines, these points right here. Why don't we want these guys? Because we have a maximum number of balls of at least 1 that will be copied. There's 2. So we need to be able to set up a scenario where we could just have a single point. Can't do that with those 2 guys. So what we're going to do is further down the network, we're going to delete these 2 endpoints off so that we have pure control over the number of balls that are on the bench. If we did not delete these off, you could say that the rule set forth by Houdini would be that there will always be at least 2 balls on the bench, and we don't want that scenario. So the number of balls per bench, this number right here, which we know goes from 1 up, needs to control how many points will be on this line plus these other 2. These other 2 are very important. Later on, they're going to be deleted out, so we have to take them into account. So instead of saying that our points are set to the max balls per bench, we're actually going to say that we're going to start out with the 2 points that we already know exist plus max balls per bench. Okay, so let's say that I wanted 3 balls maximum to be on a bench. So here's our line. We start out with our endpoints. 1, 2, 3. Because if max balls per bench is set to a value of 3, and these 2 points here get deleted, how many points are we left with? We're left with 3. Everything jives. So that's what we're looking for. So now that we have the line in place, let's just go ahead and draw the line coming on down. And how about we just turn right around and connect this guy into a delete SOP. And we tell it that we're going to delete out points. And we just say delete out point 0 and delete out the last point on the line itself. And then we're going to be left with just those 3 points. And that's exactly what we are looking at. And I believe that's everything that we're going to do in this video. But what I would like to point out that as we work further and further into conditioning the points on each of our benches, we're going to take these guys, we're going to end up shifting them in various directions, and that is just to kind of randomize the look of the crowd distribution onto our benches.
And we're going to be modifying the simple expression that we've got at the moment that's in our points parameter to control randomly how many audience members are assigned to each bench.
Exactly, because the very first part of the parameter name says it all. This is the maximum number of balls. So if we have 3 max, we may have one bench with a line that has these 3 points on it, yet we may have another guy that just has 2. Okay? And if we don't start shifting these guys, then they're all going to be in a line, and that's going to look kind of rough. There's another thing I'd like to point out as well that we're going to do. As we start taking into account all of our different rows, so as we go back, notice the way I'm drawing this. Our line's getting bigger. Let's say the maximum number of balls on each bench is 6. 1, 2, 3, 4, 5, 6. So let's say that looks good. 1, 2, 3, 4, 5, 6. Getting a little crowded. 1, 2, 3, 4, 5, 6. That's getting very crowded. 1, 2, 3, 4, 5, 6. All of these spheres right here are overlapping with one another, and that's going to look really bad. So another thing we're going to do in regards to modifying the point will be to bias this towards the back in such a way that even though the maximum number of balls per bench is X, as we work our way down our rows towards the front, we can't have that many, so we'll have to drop the number down. This is very important so that we do not have overcrowding as we get to our very first row. Okay, so that's just a real quick look at everything that's coming up, but once again, in this video, all we're going to do is get this line sitting flush on top of our original constructed bench, and then we're going to set up the number of points on it in such that we can adjust that max balls per bench custom parameter up on the asset and see that many of points plus our 2 outer points, and then we'll delete those 2 outer points.
Yes, it's worth reiterating that we've gone with this approach using a line and a delete because the line swap gives us so much power in its other attributes in terms of we can control the number of points and its positioning so easily that we just needed to overcome the fact that we couldn't have less than 2 points rather than taking a completely different approach to generating these points.
That's correct. But this is Houdini, and there are a ton of different ways
there really are.
that you can come up with points that are sitting on top of this bench for copying your crowd characters to. In our case, this is going to work really well for us. So with that, we'll go ahead and jump over into Houdini and start putting this together.
Alright, so let's jump over into Houdini.
Okay.
And our job in Houdini for this video is going to be nice and simple.
I would think so. A line and a delete.
Cool. So I'm going to jump over into Houdini. And where are we going to create this line? Well, this line is going to be created up where we create our benches. And it's going to be wired into the merge. Let me just template and untemplate that. We got a node selected. There we go.
Yeah.
So we're going to wire it into our merge along with our bench. So when our bench gets duplicated around using our 2 copy stops, our line for copying our audience gets duplicated around as well. And because of the fact that the way we've got stamping coming up from our copy for benches for rows, we can rely on our bench's size to set our line size.
Okay.
So I'm going to drop a line swap in just over here so we can work with this area of the network. So I'm going to create a new line, enter and enter. And let's rename this to something like audience template line. Audience template line. And before I do anything else, I'm going to wire this into our merge bench tubes and seats so that it gets merged in with all of these guys and copied around when everybody gets copied.
Nice.
Fantastic. So we're dealing with a number of parameters on our line to set up the line. I guess most importantly we should change the direction to be X because currently he's going in Y. So direction of 1, 0, 0 will give us a direction of positive X. And then let's change our origin in X so that we center up on the origin. So we'll take a negative distance divided by 2. And that will center us up nicely on the origin. Now for our origin in Y, we want to sit up on top of the box. We saw on the whiteboard how easy this is. We're going to take our bench box, translate Y parameter, and we're going to add on to that half of the bench box's size in Y. So bench box size Y divided by 2. And if we template in merge, we'll see we're sitting flush with the top of our box.
Very nice.
Cool. So all that's really left to do in terms of the basic parameters is to set our distance to be the length of the box, and then we can create our maximum balls per bench parameter up on our asset.
Okay.
Cool. So our distance is going to be our size X of our box times 0.9. So let's grab the bench box size in X and times that by 0.9. Now, it's going to look like everything exploded. We do need to force the network to recook in order for everything to work properly because, of course, this is relying on a stamped parameter. So once we recook the network, we can see our lines. Let me bring our visibility down here. Turn
Very
on points
nice.
will probably make things nice and clear. We can see our lines all copied to the benches and slightly smaller than the width.
In every
of the
case,
bench.
they're 10% smaller and
Exactly.
centered up on each of our benches.
Awesome. So all we've really got left to do is control of our points at a very basic level. And to do that, we need that max balls per bench parameter up on our asset.
Okay.
So I'm going to right click on our asset, come down to type properties. I'm going to come over to the parameters tab. I'm going to create a new folder. We've got our bleachers folder. I'm going to create an audience folder. So I'm going to click drag another folder into root. And this folder is going to be for our audience. And inside our audience folder, I'm going to create an integer parameter, which is going to be max balls per bench. And I'll give that a label of max balls per bench. We're going to lock this with a minimum of 1, and for now I'll leave it unlocked with a maximum of 10. And I just need to shrink this down so I can click on accept. Fantastic. So we've got on our parameters the bleachers folder, and we've got an audience folder with our ability to set max balls per bench. It's kind of not how I wanted that to be laid out. I did want this guy to be up here. Let's see if we can fix that before I continue. So I right click, come down to type properties.
Yeah, yeah. There we go. Nice.
No, it's just the way Houdini's interpreting that. That's kind of crazy. So, well, we'll carry on working because it's not a huge issue.
Yeah, that's interesting. Well, we'll talk more about that a little bit later. We'll play with it off screen because normally that puts it right beside it.
It really should be.
It's what it's done in the past.
Houdini interpreting that crazily. Anyway, so we've got our parameter at least, which for now is all that's really important. I'm going to come back up to our line, and I'm going to set our points. We saw we're going to use 2 as the minimum because we're going to delete off the 2 endpoints and add that parameter to the 2. So let's grab our max balls per bench. Instantly that adds a third point to the line. Let's just look at a single bench so we can actually see what's going on. There we go. So we instantly add a third point to the line because we've got 2 plus
zoom
1.
on in a little bit more.
Just onto one of the benches?
Yeah. There we go.
What if I turn on point numbers?
That's even better, yeah.
Clearly see the center of the bench is the most important thing. So as we start increasing our max balls per bench, we can see we've now got the 2 ends plus 3, 4, 5, and so on.
So leave it up go up to 6. All right, so look up at the top bench there. You'll notice having those 6 points between the 2 outer points. Okay, good. Now watch this. As we work our way down towards the very first row, look how
crowded.
Yeah, it's very crowded.
And which is exactly why in a few videos time we're going to be dealing with biasing the number of points so that we have larger numbers towards the back of our stadium.
Yeah, that's going to be very important.
Yeah.
All right, so now we can delete off those points.
Yeah, and that's nice and easy. I'm going to wire a delete SOP after our audience line template. I happen to have a delete in our history, so I'm going to left click to select that. Enter to drop that into our network. I'm going to rename this to delete end points. Let's see if we can actually see our line. Fantastic. So how do we know how to go about deleting our endpoints? Well, we can delete by a pattern. We know our first point is point 0. So let's delete point 0. So I do need to change the entity over to points, otherwise primitive 0 is everybody.
Right.
So we delete point 0 to get rid of our endpoint. This end is point 7, and we can use $n to grab our top point number because it's our number of points minus 1. We have 8 points, minus 1 is 7. So we can simply put a space after the 0, use $n in our pattern, and that's going to grab our first and our last points and delete those off.
Nice.
So now we can come back to look at our copy. And let's turn off, there we go, and get rid of the templating. So we can see we've got our line with, if we bring up our parameters and zoom in on a couple of these guys, currently with 1, 2, 3, 4, 5, 6, because we've got 6 points. So we decrease that down, we can indeed hit 1 point, which we wouldn't be able to do if we didn't add 2 points and then delete out the endpoints.
Exactly. Okay, and with that, that's pretty much everything that we had planned for this video. In the next video, Steve, what you think? Let's go ahead and get some randomization going there?
Yeah, that sounds awesome.
So that not everyone has the same number of points per bench.
Yeah.
So with that, that is going to wrap up this video. Thanks a lot.